Students, this is your lesson 1.6 for chemical reactions. Your teaching point in your notebook, I'll be able to determine which claim is responsible for the reddish brown substance in Westfield's water. Okay, again, I would be able to determine which claim is responsible for the reddish brown substance in Westfield's water. All right, let's work on the warm-up here. Same warm-up that you have on Amplify, right? So if you want to amplify and you want to this lesson 1.6, your goal is to drag and drop these over the respective blank spaces. All right, so let's do it here on Nearpod. Below are atomic scale models of two different substances. Use the terms in the word bank to label these models. Use each of the terms only once. All right, so pause this video and think about where these four would go. You can only use the word bank once. All right, when you have an idea of an answer, of the answers, unpause it and listen to me. Okay. So the easiest one we have is atom. That's the easiest one to get. And we have an atom key down below. Your atom key, we have capital K for potassium. We have capital C lowercase l for chlorine, capital C for carbon, and capital H for hydrogen. Now looking for one single atom by itself, and the only single one by itself would be at that spot. All right, so that one Cl is an atom. All right, next thing we have is, so with another easy one, repeating atom group. We have this section here, we have a KCl, and we have CH4, which is methane. All right, so we experienced the word methane for the substance on Lake Titan, with it evaporating from 2007 to the 2009 picture. Right, CH4, which is a hydrocarbon. This is your repeating atom group. So KCl's will repeat all over the place, and your CH4 would repeat all over the place. All right, next one we have is extended structure. That's a nice easy one. Your extended structure should be that section right here. All right, now if I go dig back here to extended structure, let's just revisit the article, atomic zoom in. All right, the last paragraph has extended structures. So an extended structure, a structure formed by repeating groups of atoms linked together in a large network. All right, in extended structures, the atom groups repeat over and over and over again with all the atoms connected to their neighbors. Right, that is going to be your extended structure. All right, and that's your extended structure. All right, so this is going to be repeating over and over and over again. The KCLs all are touching and they are repeating. Last one's molecules, right? So I'm going to extend this over to that section here. And these are two molecules of methane, CH4. You have CH4 and CH4. Two molecules of methane. All right, here we have a total of 1, 2, 3, 4, 5. We have 6 molecules of KCl, of potassium chloride. But this is all touching and extended, repeating. All right, thank you for working on that. All right, word relationships. All right, how did you label the models? All right, we just explain the labeling of the models. You'll use these words to create sentences that explain why different substances have different properties. This will help you respond to the people of Westfield. Now, Westfield, they have a situation, right? People of Westfield have this reddish brown substance coming from their pipes from the pipes leading to their households. And then the well water does not have the reddish brown substance, that has fertilizer in it. All right, so we're going to have to use these words in our sentence or sentences. All right, so think about some ways you can utilize these words. All right, and pause it. And then once you have some sentences, right, you could unpause and listen in. All right, thank you. So using some of these words, right, we use models to represent or to show atoms because atoms are too small to be seen with the naked eye. We can say that different substances have different properties because they're made up of different atoms or some different atoms, and we use models to observe those substances. Right, there's many ways we can utilize these words. All right, let's see what we have here. All right, let's share some sentences you create. Okay, so I'm hoping that you definitely paused it and try to create some of your own sentences. All right, let's get this down, please. Key concept number 3. Key concept 3 in your notebook says, substances have different properties because they are made of different groups of atoms. These groups vary in the type or number of atoms that make up the group. Once again, substances have different properties because they are made of different groups of atoms. These groups vary in the type or number of atoms that make up the group. So sometimes they can share the same type of atoms, right? They can, like for instance, ethyl butyrate and isovaleric acid both are liquids, and both contain carbon, hydrogen, and oxygen. right? But the way they are structured, the way the atoms are arranged, and the number of atoms, right? Ethyl butyrate is C6, isovaleric acid C5. Hydrogen for ethyl butyrate is 12. And then isovaleric acid had 10 hydrogens. They both had 2 oxygens, but because they have different atomic numbers for the carbon and hydrogen in different arrangements, then they have different properties. All right, let's get this down, please. Key concept 4, groups of atoms repeat to make up a substance. Groups of atoms repeat to make up a substance. All right, so going back to our previous unit, methane, right? Methane in the warm up was CH4. It contains 1 carbon at the center, and we have 4 adjoining hydrogens that are bonded together. Right? That's a grouping of atoms to make a substance. You had the KCl's, you had the potassium chlorides in the warm-up, right? The KCl's will come together, right? And then if you put more and more of these together, you can make an extended structure. And they're repeating groups of atoms that can be used. All right, activity 3, identifying the reddish-brown substance. Okay, you already made observations of the pipe, the fertilizer, and the reddish-brown substance. You will first review your observations and think about which claim is best supported. All right, so this is going back to our first lesson, 1.2. All right, it says a water mystery in Westfield. All right, this was activity 3, hands-on observing substances. And this might have been under, page number 2. What did you observe about the sample of the pipe substance? What did you observe about the fertilizer? And what did you observe about the reddish-brown substance? So, right, it was your job in lesson 1.2 to make your observations. Okay, you will first review your observations and think about which claim is best supported. I believe what you typed in 1.2 should be should be connected to your 1.6. All right, so you should be able to see it. It says here return to source activity. Yeah, so this is the 1.2 activity 3 activity. All right, so you should be able to see it. Okay, you'll examine and discuss these models so that you can use them as evidence in your explanation to the people of Westfield. All right, so we definitely need to use this, right, to help us. All right, so the pipe substance would have repeating atoms of Fe. Right, now Fe, according to your key, is iron. Fertilizer, the repeating group of atoms. Now, there's no group here. This is just an atom by itself. You put a whole bunch of irons together, you get to see what iron is, and that's the pipe substance. Here we have Na, which is sodium, capital N, lowercase a. We have 3 capital O's, we have 3 oxygens, and we have 1 capital N, for nitrogen, which is NaNO3. And then the reddish brown substance, the repeating group of atoms, is Fe2. We have 2 Fe's and 3 oxygens. 1, 2, 3. Fe2O3. All right, so we have 3 claims that we're going to work with. Claim number 1 is that the reddish brown substance is the same as the pipe substance. We have the reddish brown substance is the same substance as the fertilizer, right? Or claim 3, that the reddish brown substance is neither the pipe substance nor the fertilizer. Right, those are 3 claims that we're trying to figure out. All right, I believe we already have this written down. Things that are too small or too large to see can be studied with models. All right, we already have that written down. All right, so what is the reddish brown substance in the water? We have our 3 claims. All right, so what I need you to do is really think about which claim it's going to be. Again, claim 1, all these begin with the reddish brown substance. All right, claim 1 is the same as the pipes. Claim 2, same as the fertilizer. Claim 3, it's not the same as either the fertilizer or the substance that makes up the pipes. All right, based on the properties you observed, you were able to tell that the substances, okay, are not the same. Right, visually speaking, the pipe substance was black or dark gray. Right, it had a different texture, of course, had many different sizes to them. The fertilizer, white in color, right, you mentioned in class to me that it has crystals to them, or like a sandy texture. And the reddish brown substance, when shaken, sounded like a powder. Definitely, all 3 have different colors. Right? So, again, you notated all that. However, the atomic scale models help explain why these substances are different. Each of the substances is made up of different repeating groups of atoms. All right. So we have iron as Fe, fertilizer is your repeating group, right? NaNO3, and then your reddish brown Fe2O3. All right, now that we have an atomic scale model of the reddish brown substance, we can also identify it. Right, the substance is called iron oxide or rust. Right, that is what this reddish brown substance represents. All right, your job is to write an argument to the people of Westfield in terms of what claim it is right now at the end of chapter 1. All right, so again, residents of Westfield found a reddish brown substance coming out of their water pipes. We have the neighborhood of Westfield. Dr. Young took the sample of water from Westfield's well. That's here. She did not find the reddish brown substance in the sample. However, she did find some fertilizer. All right, you have a nearby form, perhaps putting that fertilizer in the well, maybe by accident. All right, in your arguments, you will state your claim about the identity of the reddish-brown substance. Use evidence from both your observations and the atomic scale models to support your claim. Use the vocabulary words you've learned. All right, so your vocab words, you want to use the words atoms, model, property, and substance in your writing sample. All right, let's go to your writing sample, and you're going to be writing this down. This will be under page number. This will be page 3. All right, you're going to write this down. Now, page 2 you can use to help you, right? This is your evidence that you're going to use, right? The models, the atomic models. Okay, here we go. Dr. Young wants you to explain what the reddish-brown substance is to the people of Westfield. As you write your argument, remember to state your claim about the identity of the reddish-brown substance. All right, your claims are here. It's claim 1, claim 2, or claim number 3. Use evidence from both your observations and the atomic scale models. All right, so page 1 is your observations. You're going to use that along with the atomic scale models. All right, that's going to be 2 pieces of evidence you need to include. Include the vocabulary words listed below in your argument, which is going to be atom, model, property, substance. You have your claims right here. You can actually just copy and paste whichever claim you think is going to work for this. And there is one legit answer that it has to be. Okay, when you're writing your argument, make sure to include the claim. All right, claim goes first. Followed by maybe your visual evidence. Then reasoning for visual evidence. 4, atomic scale model evidence. 5, reasoning for the atomic scale model evidence. And number 6, restate your claim. All right, that's going to be your goal, right, to finish up this argument during class time. And that's on activity 3, page number 3. Please remember again, there should only be one claim chosen based on your visual. All right, so here, based on your visuals, your observations from 1.2, and your evidence for the atomic scale models. All right, ladies and gents, get that in, completed, submit it. If you don't have time, or if you need a bit more time, make sure you finish this. I want to try and look these over maybe on Monday or Tuesday of next week. All right, thank you and have a great day.